So the fundamental particles, as we discussed earlier in the introduction, so the fundamental particles, we can have leptons, we have quarks. Leptons are the particles which experience weak nuclear force, where quarks are the particle which experience strong nuclear force. Now, what are the characteristics, like the properties for these leptons? They are the lightest group of particles. They have spin half. What is the meaning of spin half? It means, like example, if you have a particle, okay, if particle rotate half, you will see the same face again. That's called spin half. And if a particle spin is 1, like example +1 or -1, plus and minus is only showing that, like a spin +1 and -1 shows that when there is a one complete rotation, then you will see the same phase again or same point. Like, but spin half means like phases are same. So if when it is completely rotated half, it will look identical what was there initially. And plus half and minus half only shows that one is clockwise, another one is anti-clockwise. So they are acted upon a weak nuclear force that we'll discuss later. They are fundamental particles, so we cannot further divide. You cannot break them into further smaller particles. Lepton number, what is a lepton number? For each lepton, the lepton number is +1, and for anti-lepton, the lepton number is -1. And all other particles have lepton number 0. So what these are the fundamental leptons. You have to learn the names for each lepton: electron, electron neutrino, muon, muon neutrino, tau, and tau neutrino. These are particles, and there will be antiparticles of this. Like example, if electron is there, what will be the antiparticle of electron? It will be positron. What will be the symbol for positron? It will be, you can write E bar or you can write E plus. What will be the charge of positron? It will be positive. So for every particle there is antiparticle. Electron, so you have to learn the charges also. Electron charge is -1, means what does charge -1 means? Actually, actual charge, this is a relative charge, you can say. Actual charge is 1.6 into 10 to the power -19 coulomb. But because the charge of electron is same as charge of muon and charge of tau, so when we take a simplest ratio, relative is -1, -1, and -1. And electron neutrino, muon neutrino, and tau neutrino, these are neutral particle, does not have any charge. Is it clear? So if I say what is the charge of anti-electron, so what will the charge of anti-electron? Plus. But what will be the charge of anti-electron neutrino? That will be 0, because for 0 you cannot write +0 or -0. This will be +1, 0, +1, 0. And what about the lepton number? For lepton number, for each lepton it is +1. So what is the lepton number of this? +1, +1. All of them have a lepton number +1. And what is anti-lepton? The lepton number for antiparticle? -1. Is it clear? The concept of leptons are the particles which experience weak nuclear force. These are the characteristics. So I want you to copy the characteristic of these leptons and this table as well. You have to learn the symbols, you have to learn the charts. Then we have the second fundamental type of particle which experience a strong nuclear force. We call them as quarks. So basically there are 6 quarks altogether, and each quark is having anti-quark. And what are the names of the quarks? It's easy to remember the names. It's not like up quark, down, top, bottom, charm, strange. And all the positive degrees, it's easy to remember the charge as well. All the positive degrees have a, like up, top, charm. So they have a charge plus 2/3. And all the negative degrees have the charge like down, bottom, strange. They all have a charge minus 1/3. So, and all these quarks, I will show the table which you will copy. So all these quarks will experience a strong nuclear force. So there are basically 6 quarks, and each quark is having anti-quark. Like example, up, the charge of up is plus 2/3 times the charge 1.6 exponent minus 19. So if what will be the anti-particle? So it will be anti-up, and what will be the charge? The charge will be minus 2/3. Same thing if you have down, the charge of down is minus 1/3. So what will be the charge of anti-down? It will be plus 1/3. So for every particle there exists antiparticle. So they also have antiparticles. Then if we have group of 3 quarks together, like if we have a group of quarks and there are 3 quarks inside, like you have up, and down. So if there are 3 quarks together, what we call this quark? We call this quark as baryon. If 3 quarks are together, we call baryon. But if there is quark and anti-quark, mean 2 quarks are there, and one is quark, another one anti-quark, but it's not like the same one. It can be any other anti, like up and anti-down. So what we call that combination? We call that combination as mesons. And meson and baryon collectively are known as hadrons. So quark can be up, down, top, bottom, charm, strange. These are the quarks. For every quark there is anti-quark. Like example, up there will be anti-up, down anti-down, top anti-top, bottom anti-bottom, charm anti-charm, strange anti-strange. And there's a charge so plus 2/3, plus 2/3, plus 2/3. This will be minus 2/3. Why minus? Because it's an anti-particle. And if it is minus 1/3, this will be plus 1/3. So there are 6 quarks altogether. They experience strong nuclear force. Quarks are constituent particle of hadrons. They make hadron. And what are hadrons? Meson and baryons are known as hadrons. And all these quarks and anti-quarks, their lepton number is 0. And what is a baryon number? Baryon number for every quark, the baryon number is plus 1/3. This is not charge. For every quark, it is plus 1/3. And for every anti-quark, it will be minus 1/3. That's called a baryon number. Baryon number and lepton numbers application you will study later in this chapter, like why we use this baryon number or lepton number. Basically it is used to show conservation of a reaction, whether a reaction will occur or no. So right now for this part, what you will copy, I want you to just copy the, there are 6 quarks altogether. They experience strong nuclear force, and quarks are the constituent particles of hadron. And when we say they are fundamental, it means we cannot break down into smaller. And quark have not been observed in isolation, like they're always together with the other particles, not isolated. Like you don't find a free up particle or down particle, they're always in a group. And for every quark, the baryon number is 1/3 and anti. The spin half means they have, like every half rotation, they will see the same phase again, and they have lepton number 0. So for quarks, the lepton number is 0, and for leptons, the baryon number is 0. Copy this, the quarks. Then you have to copy this table for the name of these particles and their charges with a symbol. Up symbol U, down D, strange S, charm, top, bottom. And this table is about their masses. You can see up, down, straight. So which one is a massive particle here? The top quark is a massive particle as compared to other. First copy this table. This is in terms of the mass. So up mass is about 1.5 to 3.3 mega electron volt per c square. We already discussed. Down from 3 to 6. Exact value you don't have to learn. The important is identifying like which one is heavy and which one is lighter. So order you should know, not the exact value. Like up is the lightest quark, where top is the. So up, down, strange charm, bottom and top. So this one is massive, more mass, and this one, so heavier particle, and at the top you will have lighter particle. So copy this part as well. Then what are hadrons? Basically, combination of the quarks are known as hadrons, and hadrons are divided into two classes. One is called baryon and another one is meson. Baryon means when three quarks are there, baryons are the heaviest group of the particle, and when three quarks are together, we call them as baryon. And if quark and anti-quark, then we call that as meson. Actually, what is proton? Proton is also a baryon. Why proton is a baryon? When we check the structure of a proton, actually proton consists of up, up and down quark. So as it consists of up, up and down, so up, up and down, what will be the charge of up? Up is plus 2 by 3. What is the charge of another up? That's also plus 2 by 3. And what is the charge of down? It's minus 1 by 3. When I solve this, what I will get final result? It's plus 4 minus 1 by 3, which is equals to 3 by 3, which is equals to plus 1. So actually proton is what? Proton is a baryon. Proton is a combination of three quarks, which is up, up and down. As well as neutron. What is neutron? Neutron is also a baryon. How neutron is a baryon? Neutron is actually down, down and up. So down, down and up. So what is down? Down is minus 1 by 3 charge, minus 1 by 3 charge and plus 2 by 3 charge. So when I solve, what I'll get final charge? Resultant charge will be 0. So that's why the neutron, there's no charge of neutron because it consists of three quarks in which the total net charge is 0. That's why neutron overall charge is 0. And what is the baryon number? Baryon number for each quark. Like if there is a quark, the baryon number is plus 1 by 3. And if there is anti-quark, then it will be minus 1 by 3. So up, up and down. So up, up and down, what will be the baryon number? So for up, it is 1 by 3 because it's a quark. For another up, it's also 1 by 3. And the down also, it's a quark. So I'll have 1 by 3. When I solve, I'll get baryon number as plus 1. So baryon number for each baryon, it's plus 1. For every baryon, it's plus 1. And for anti-baryon, means the antiparticle, the baryon number will be minus 1. And they are not the fundamental particle. Why we call they are not fundamental? Because they can further divide it into quarks. And what are the particles which you have to learn? You have to learn proton, neutron, lambda, sigma positive, sigma neutral, sigma negative, psi 0, psi minus 1. And these are the symbols which you have to learn for these particles. Is it clear, the concept of baryon? So actually what are baryons? Baryons are the combination particles which consist of how many quarks? 3 different types of quarks. 3 different quarks will result in a formation of baryon. And for baryon number, for each baryon, it is plus 1. For anti-baryon, it is minus 1. This is all you have to know. There is one more part. The mesons are there, so I will explain meson because we have almost 6 minutes left. So I will share this presentation also with you. You can copy from that, or the video recording I will share, so you can copy from that as well. So what are mesons? Mesons means the particle when there is a when there's a quark and anti-quark together. It does not mean like up and anti-up, because if up and anti-up are there, within an instant they will annihilate and release energy. So when mesons, which are have a mass intermediate, they have mass between lepton and baryon. They're combination of two quarks. They are not fundamental. Why? And these mesons are short-lived. Short-lived means does not remain for a longer period of a time. There are different types of mesons: pion, pi zero or pi neutral, kaon, k0, and eta. For pion, pi positive antiparticle will be pi negative. Pi zero self is an antiparticle because neutral is there. Don't kaon antiparticle negative kaon, kaon neutrino anti-kaon neutrino, or the self particle, and eta antiparticle is anti-eta or self. Why? Because it does not make much difference to them. And so mesons have a mass which are intermediate between lepton and baryon. They have a whole number spin. What does it mean, whole number spin? Means when there is one complete rotation, then you will see the same particle phase again. That's why we call they have one complete whole spin as +1. So when we summarize this, we can simply say that particle can be quark, it can be lepton. Quarks collectively can make hadron. Hadron means if they consist of three quarks, we call baryon. If they contain quark and antiquark, we call meson. Example of baryons such as proton, neutron. Example of meson such as pion and kaon. And for meson, one more thing, the baryon number of meson is always 0. Why the baryon number is 0 for meson? Because you have particle and antiparticle. And we know that the baryon number for each quark it is plus, and for anti-quark it is minus. So this is anti-quark, so it will be -1/3, and this is quark, so it is 1/3. So what is the baryon number? So baryon number for meson is 0. So this last part, particle head, can be referred which experience strong nuclear hadron, experience weak nuclear lepton. Hadrons can be baryons, mesons or mesons. Baryon means 3 quarks, meson means 2 quarks. This part will all experience strong nuclear force, the hadrons, and the particle which experience weak nuclear force, we call them as lepton. So these are the fundamental particles or basic particles. Is it clear, the concept here?
Yeah.
Then the conservation we will discuss next class, but I want you to memorize these particles as well as their charges. Important thing is to know their charges as well, the symbol for each particle, because the other topic is related to identifying whether the reactions will occur. So we will discuss once you learn these topics. So next week we'll discuss the particle interaction. and as well as the question from electrostatics. Any doubt related to this class?
No.
Okay, so I'll end the session and share the recording.